All right, solving a secant equation. Now, whenever you guys are solving trigonometric equations, you got to first get the trig function alone. So let's get busy on that. I don't know what this extra stuff is. Okay, so I'm going to have secant x, 1/2 secant x equals 1, because I have to add 1 to both sides to get rid of that 1. It always makes it easier if you try to get rid of the addition and subtraction operations first. Of course, there's other ways to do that, but I think that's the easiest way. And then to get rid of that 1/2, we're going to multiply both sides by 2. Now, if you thought divide both sides by 1/2, remember that's the same as multiplying by 2, multiplying by the reciprocal. After that, we get secant x equals 2. And you might not have this memorized. We usually only have sine and cosine memorized, as well as tangent in the unit circle. So one thing you can do is you can take out that secant and you can put in there 1 over cosine x equals 2. And then then hopefully you guys can see that you can now write cosine x equals 1/2. And that's because what you would do to get cosine x out of the denominator is by multiplying both sides by cosine x. Then when you do that, the cosine x's would cancel out right there, and you'd be left with 2 cosine x equals 1, which is how you would be able to get to the 1/2. You just divide both sides by 2. All right, so now which quadrants for our unit circle, in our unit circle, would you get a positive cosine of 1/2? And that would be quadrant 1 and quadrant 4. If you look at your unit circle, you'll notice that the angle right here, which is pi over 3, gives you a 1/2 for cosine, the x value. And then for the fourth quadrant, you would have 5 pi over 3. That would give you a positive 1/2 for the x. And so our answer for this part right here, just 0 to 2 pi, would be pi over 3 and 5 pi over 3. Now, if you want to do the general term, which is what the other one asks, this one asks you to find the general form, or the general term, you would take the answer and you would add the period times n. So if I look at this right here, the period, since there's nothing multiplying to the x, the period is still 2 pi. I don't know if you guys remember back in the day when you guys learned how to graph these, if you had something multiplying to the x inside the trig function, that's the only thing that would change the period. And since the period is not changed, we just use 2 pi. And then the other one would be 5 pi over 3 plus 2 pi n. So there's your general terms, and here are the answers, or the general solutions, and here are the answers, the specific answers for that looking window. I just want to remind you guys, trig functions repeat. That's why we have this. We will hit the solution multiple times. So let me draw a picture of that really quick. So secant, let's see, we use tangent. Secant and tangent, or I'm sorry, not tangent. We use cosine, and cosine repeats itself. I'm sorry, my writing is extra bad today because I'm having issues with my stylus. Okay, so this is what secant looks like. And we're trying to find out where secant equals 2. And so 2 would be right about here. And if I were to draw a line right here at 2, you can see that we're intersecting right here. And then if I add the period, we're intersecting right there. And if I add the period, we're intersecting right there. So every time I add a period, then we get a new solution. That's why I have the general solution looking like this. For the other one, this guy, if I add that one, we add a period to that, we will get that solution. So that's why we have to have 2 general solutions.